Okay, it's 10:30, 10:33 Dubai time. Let's get started. Good morning, maybe good evening, good afternoon, wherever you join the session. Happy to be there with you for a 50-minute workshop. So you will be able to do hands-on with me if you feel keen to. There is nothing to install. We are together for 50 minutes, so let's get into it. I'm Cedrick Lunven. I'm leading the developer advocacy team at Datastax. So Datastax is the company pushing for the open source NoSQL database Apache Cassandra. So I'm a trainer, speaker there, but I'm also a Java geek. I created a couple of APIs on multiple specification, multiple languages, and especially in the product FF4J, feature flipping for Java, where you can enable or disable application at runtime. A little bit of housekeeping. I'm checking the chat and question. I can take question live, no problem. We do have time. If you want to join my network, you have my coordinate on the screen, GitHub and LinkedIn. Feel free to invite me. We'll be happy to have you. So for the material today, for the hands-on, here the QR code, you can scan it. This is the GitHub repo. I share the link in the chat. There you will find everything you need. So step-by-step instructions, but also the slides of today. So, but nevertheless, please stay with me. All right, so that's the agenda for today. Let's go back to the data API. Today, I will talk to you about building APIs on top of data layer, data services, DAO, data access object. So three main API implementation, Ref, GraphQL, and gRPC. Let's try to find which one you should use and when. Then what is a data gateway? We'll explain that. And an open source project, it's called Stargate, stargate.io, that will provide you all the APIs for you, not having to code actually. Then demo hands-on for you, and some sharing resources at the end. So first, data API. You might think, why would you put some HTTP APIs on top of a database, right? We are using JDBC drivers for ages, so what's new? What would change? Well, first, there are so many databases out there, and each database uses its own binary format, own languages, depending if you are using big data technology, NoSQL, and even in NoSQL, graph database, document-oriented database, there are many of languages. So Cypher is for graph, GQL, CQL are for query language, Cassandra query language. And yeah, it's not only, there are a lot of technology, and you want to have a simple way to save a JSON, retrieve a JSON, and get rid of it. Second is, you need some abstraction. You don't want to know exactly how the data is stored, how the database works. You just want to create, read, update, delete with an API, right? And speaking of databases, you do not like to install them. When you develop locally, you can use Docker or Kubernetes. But even then, that's not the easiest. So what if you could interact with databases like any other services using an API on the web? So that's why. And on the operator side, database administrator side, if you let developers use your database, they will probably execute all kind of queries, put all kind of index, and put some stress on your database. If you put an API on top of it, it's kind of an abstraction, and you protect yourself against stupid queries done from developers. Yeah, I know you know what it feels. And it's not only about usage, that's also about security. You don't want to open the wide range of ports that could be, harmful. You never know what will happen with those. And what about the skill? Each time you start a new project, if you are using some weird databases, you need to find the niche people that will be able to know that languages. Well, if you expose an API, so it's easier to kickstart project. And if you want to expose your data to the rest of the world in a secured way, and the API, public API is really the good way to do so. And last but not least, and we have been doing that for a long time, and it's not only on data API, of course. The API management solution with the API gateway proxy on top of your service will get you a lot of technical features, security monitoring, throttling. But I think we are doing that for almost 10 years now. Yeah, time's fly. All right, so what APIs do you want to expose? You have a couple of tables, couple of data. Which one should you use, especially for data APIs? So you can start with REST, the all-star REST replaced SOAP, probably 15 years ago now. You may still have some SOAP services here and there, but REST is everywhere. Okay, it leverages the HTTP verb, and everything is a resource, and you will use get, post, put, delete to interact with your data. Okay, this one is probably the most well known. Second, gRPC created in 2016, pushed a lot by Google, still working on HTTP, actually HTTP2. Here, the focus is all about performance. You are working, doing some binary serialization using something called protobuf. So you define what will be your interface using protofiles, and some clients are generated based on your interface. Because it's binary, because it's used multiplexing at the HTTP level, the purpose is really to target speed. Also, as the interface is exposed with protofile, it's pretty easy to have multiple clients, okay, in multiple languages, Java, C#, even some Rust, Erlang, whatever. Google provide a lot of generators for you to build clients based on the specification. And the third I want to tell you about today is GraphQL. So this time created as well in 2016, but this time by Facebook. And it's also leveraging HTTP, but not using the standard HTTP verb here. I mean, just post. So you have a single endpoint, and there you will, based on the strongly typed languages, so GQL, GraphQL query language, and the schema definition language, you will define some objects and some function to interact with these objects. Okay, so contract first sounds familiar, right? So as soon as you define your GraphQL endpoint, what is cool is for your client, they can shape the request in a way that's exactly what they need. They provide only the field that wants to retrieve. So it's way less verbose. So if you think about mobile, where the bandwidth is not as good, you want to reduce the amount of data on the network. In GraphQL, it's very useful. Okay, that's for the definition. And as an architect, and probably especially in bank, I used to work a couple of years for financial services. You like to have a catalog of technology where you should use each technology and when, and you are doing some decision tree. So what if we try to do a decision tree to say, hey, for this type of services, you use this API and so forth and so on? Well, let's design some criteria based on the conceptual data model, maybe based on the queries you want to know, based on the existing technology inside your company, based on the skills of your developer, and based on who are you targeted this API to. Is it internal, external, public, private? A lot of questions you might ask, right? So if I try to design a matrix, it's super hard to understand, especially because some terms here are in French. And, with this matrix, if you try to build that decision tree, you end up something like that. And it's a nightmare. It's a nightmare. So this is not the way we should do. There is no one decision tree that everybody can use and give you when you should use REST, gRPC, or GraphQL. On the contrary, because I implemented multiple of each one, here I give you my SWOT analysis. So strength, weakness, opportunity, and threat. So REST. REST is very good to decoupling client and server. I told you, an abstraction on top of what you want to serve, leveraging HTTP verb. So the schema is on read. So you need the schema to be able to, it does not expose the specification. So you need to know that specification first. REST is there for a long time. So all the tooling like API management, the new API gateway in the cloud providers are all exposing REST, right? It's the most known. So if you want to start from scratch, in this REST could be good. New project, it's the easiest. Also, if you look at the resources, you can put some major version there. And as such, it's pretty easy to have multiple versions working side by side, even in the same runtime. It's just different endpoints. Now, REST is not a silver bullet, as you might expect. Otherwise, we will only use REST. So what's wrong with REST? Everybody knows that REST is cool. So what's wrong? So first, as you can see here, it's pretty verbose. So when you invoke a REST resources, you get everything. First, you cannot filter part of the response you want. And you get this huge JSON, which is still better than XML, but still quite verbose, right? You cannot know without specification like OpenAPI or Swagger specification, you cannot know what are the resources available. Okay, it's not part of the REST design. And you should consider REST like resources, so interacting with the data, but not executing some function like command like. You can do that doing some post, but it has not been designed for that. So REST is de facto a CRUD, create, read, update, delete way to expose data. So that's superstar for data API. It's relevant to do read and write at runtime, so OLTP. It's great to do public API and web API, easy to consume, best to adapt with API management solution. Yet, you create so many resources for any services that it's better to limit the scope of a REST API to a business domain. So think about microservice or bound-in context. Of course, you can have multiple REST API, but one should be really limited to business scope. Okay, this one was easy because you probably already know. So now what about gRPC pushed by Google? Here it's based on HTTP with the binary serialization. It's all about performance. You will generate your clients, and the clients will be you will have 3 clients: synchronous, asynchronous, and streaming reactive. Performance. And because Google provides a lot of ways to generate the languages, it's very good for interoperability. So in a previous job, we had that application that needs to be consumed by a lot of different technology, actually. So a mobile application, a backend, but also some Microsoft app. And having the gRPC, we were able to generate the client in multiple technology very easily. Generating the client mean also strongly coupled, right? So you get the proto file, and based on that, you get the client. But if something changed at the client side, you need to get the new proto and generate a new client. It's not very flexible. It's hard to move. Okay, that's a trade-off to be super performant and optimized. Same as REST, no way to know what are the functions available, kind of a public contract. It's only based on the proto, you need those. And the protobuf serialization format is quite limited on its own. There is no multiple layer of data. Everything should be flat in the specification. It's not really easy. So at Google, it's used for inter-services communication, all asynchronous to use as much capacity as needed and have the better throughput. Some technology like Slack use gRPC under the hood because they can do some, it's RPC, right? So remote procedure call, so oriented like procedure invoking function. So it's the closest that's SOAP, where SOAP you expose, or RMI, RPC for the oldest among you, a way to expose function on RPC. Okay, GraphQL, very famous in JavaScript technical stack or even mobile stack. This is where it has been used the most. So first, which is cool, it's still HTTP and JSON, so you are not lost here. It exposes a contract specification that you can navigate and you can see everything that's available. I will show you a sample of each, no worries. You can invoke exactly what you want. But as everything else, it's not a single bullet. You have a single endpoint. So what if you want to do some fine-grained monitoring? You want to know which function has been invoked by who? It's not easy. Everybody will invoke the same endpoint. Same for security, cannot be fine-grained or versioning. You probably need to have two different runtimes if you want to create two versions of the GraphQL running side by side. It's still not the easiest for implementation. I mean, on the server side, what you want to do with GraphQL is probably federate data coming from multiple points, join, aggregate, and it's not the easiest to implement those. I mean, especially in the Java stack, backend stack, JavaScript is a little better, but still it's not exactly there yet. So especially when you interact with data. So let's imagine you have two tables, user and group, and you want to get all the details of your users for a group. Well, you will first get all the user of the group, and then for every single user, get the details, like a join. And this will do what we call the n+1 select. And under the hood, it could probably trigger a lot of low-level requests or queries against your database. So it's neat for customer because they invoke the endpoint and get everything in one call. But under the hood, at server side, you can trigger a lot of low-level queries. So the recommendation is to put some throttling just to limit the number of queries you will have against the database, not to kill the system. So the GraphQL is mostly used in something called backend for frontend. You cannot really invoke some data services directly from your React app, because you would expose the credential in the front-end app. This is not what you want to do. So you have this intermediate layer called backend for front-end, or BFF, also implemented in JavaScript most of the time, that will aggregate and create function and services exactly for your screens, your user interface. All right. Okay. So a lot of theory, always good to get these reminders. So now, what if something will get you those 3 APIs working on top of your database. And this is called a data gateway. So kind of an API gateway, but dedicated to your databases. Okay, it's a proxy that you install on top of the database and you get access to those API, right? Okay, so to implement this pattern at Datastax, we have created the open source project Stargate. So you can go to stargate.io and see, it's open source, that we have a lot of contributors, a lot of stars now, and it's being actively developed. See, like 30 contributors. So this is an API on top of your database. So you can have multiple flavors of database and multiple APIs exposed. So the first version of Stargate leverage on a NoSQL database called Apache Cassandra. So 3, 4, or DSC 6. It provides you the authentication, authorization, and as soon as you get your token, you can have data API, GraphQL API, document API, SQL API, gRPC API. And that's pretty cool. So now you can pick what you want based on your use case, and it's way easier to use. Don't need to learn about low-level Cassandra query language or to deal with the drivers, low-level drivers anymore. So this gateway, 2 parts. On the bottom is persistent extension, and on the top is API extension. And it's you can add your own. You want to create your own database, you can. You want to put a new API implementation, you can as well. I don't know. OData could be a good one. So I told you it's about Apache Cassandra. So let's take 2 minutes to remind everyone what is Cassandra if you don't know. So it's a NoSQL distributed database. So you can install that database on a single node. This is about the 2 to 4 terabyte of capacity, 3,000 transactions per second and per core. But it's a distributed database, so you want to install the system on multiple nodes. There is no master, and you can scale as much as you want. So that's pretty cool. You group the node as something called a data center or a ring. So on the ring, the data is distributed. So in Cassandra, you will store stable. So you should be familiar if you're coming from a SQL world. Each row will have a primary key to ensure unicity. That's no different. But you also have a column called partition key. Based on the value of these partition key, the data will be distributed among the nodes. And just with this slide, you realize that select star from my table, it's not a good idea in the case of Cassandra, because you will get pieces of the information coming from every single node. So it will be quite slow. This is not what you want to do. You want to build some tables and queries where each time you provide the value in red, the partition key. Okay, so Cassandra can be installed with multiple rings across multiple regions or multiple cloud, as you like. And why I give you this overview of Cassandra here is to understand the use case, especially in the bank, right? So I told you about the scalability. You can lose any of the node, and there is no master in this ring. Data is replicated, so you can lose any of the node. And you scale as much as you want. So output, high volume, every read, every write, boom, you're good to go. So everything, even streaming, Internet of Things, log analytics, time series, fit this database. Second, availability. Even if you lose a server, it's still working. There is no downtime. There is no move to secondary sites. It's everything is available. Okay, it's active. So no data loss, always on. And yeah, most systems should be always on, right? But you know, especially caching, market data, printing, inventory, and all the financing critical function is distributed. So you can have your data close to your customer. So for maybe compliance region, you need to have a data center in your country because that's the law. You can do that, or you can have data um, published across the world to reduce latencies and have the data as close as possible to the users. Caching would have been the market data would have been great as well, but you know, retail, customer experience, or customer information in the banking is also relevant. Last but not least is cloud native, and you know why I told you about that. You will see it's quite important. Um, it will scale horizontally. You will add more nodes as you need, and this is how you will build new application, right? Either using serverless or containers. And what you want to do is scale out the infrastructure when you need it. This type of database will work the same. So what I told you that, so before, when you had to connect to Cassandra using the drivers, you will specify the IP of one node, and the drivers will be clever enough to know, hey, which are the IPs of every single node and interact with your node. That's great. If you add nodes, reduce node, the drivers is pretty clever and will work with that. Okay. And this is kind of why Stargate has been picked as the go-to database first. So now if I put you the Stargate in the pictures, you put this proxy on top of your database cluster that will expose you all these nice APIs I told you about. Pretty cool, right? Well, not really. If you look at that, Stargate here is a single point of failure, SPOF. This is not what you want. So the real implementation will be that you get a load balancer, HTTP load balancer, cloud friendly, right? And get multiple Stargates that will leverage the Cassandra. And here that's cool. I mean, previously, only with the database, if you need more capacity, you add nodes, fine, because there is a limited amount of capacity on the single node. If you needed more throughput to execute more requests per second, you also scale out your cluster, add nodes. And you lose some money, you lose some disk, because then you instantiate a full new Cassandra node just for the throughput. Now with the proxy, you can scale the compute, it's Stargate, it's the API, or scale the data, that's the node, independently. And based on the use case, you can scale one or another. And when you put all that in, I don't know, for instance, a Kubernetes cluster, hey, now it's easier to scale the service Cassandra or the service Stargate as you need. Also, it's now all the API exposed are HTTP APIs, so stateless. On the contrary as previous drivers that were stateful and need to maintain a connection open. Again, if you are in the cloud or Kubernetes, you know that they tends to kill a node, a container, to a pod, to create it in another worker, and the IP might change. So again, at the database level, it's a nightmare. So because we expect that database will run more and more in containers and the cloud, you need an abstraction layer on top of it, just for you to be stateless and be easy with something familiar, HTTP, and let the gateway do all the heavy lifting for you to connect and find your database. Okay, so 30 minutes in, I think it was a lot of talk. It's supposed to be a workshop, right? So let's get rolling and go more into hands-on. And so two mode here, you can just look at what I'm doing, or you can do the hands-on with me, and you got the material in the chat here. All right. So here on my screen, on the left part, I put the README on GitHub. So it's public. So here, everything you need to have. So the slide, but here what we want is, start with the database. So all these technology, Cassandra and Stargate is available, for free in software as a service called Astra. So Astra platform, if you wish, is a SaaS platform providing you the database and also streaming, but that's not for today. And on top of the database, because especially it's a SaaS service, maybe you don't want to get this connectivity, we use Stargate to expose a lot of APIs to our customer. So it's using exactly the open source Stargate and open source Cassandra. Okay, so it's a way to provide open source. And here you see that GraphQL API, REST API, gRPC API are there exposed. There is something called a document API that I will demo, and also the what we call SQL API, which is the good old way to connect with this database, but not what we want to do today, right? We want to leverage the APIs we created. Okay, so that's the instruction. So now let's do it. Okay, so here what I've been asked to do is so create an account or sign in if I already have one. Okay, let's go. I was timeout on my session. Here we go. So here, as you can see, I already have multiple databases. So what we are told to do is create a new database called 3DB and a key space called KS1. So 3DB, you can use whatever you like for a database name, but case one, please use that for the sample to be able to copy paste all the instructions. I pick a region. As you can see, you can deploy wherever you like. Let's pick a Google Cloud region here and create the database. So the database is pending and it will soon be active. So I can exit that and see that, oh, my new database is here in orange and is pending. Because we are starting a 3-node cluster of Cassandra, it will take some minutes to start. We don't want to wait. Let's pick this already running API Dubai 2020. So here, the first thing that I'm told to do is find SQL console tab in the UI. Here it is. Okay, let's go. And let's create the, I pull that full screen just for us to be easier. Okay, so first describe key spaces. So let's see what it is in the database. Here, a lot of technical system key spaces and one business key spaces. So let's use it, and create a couple of tables. Yeah, here we are creating the schema, inserting a bit of data to be able to interact with the API with something in the database. Otherwise it's not as interesting. So if I want to insert values, I can insert values using insert into, like CQL, and I can insert values using insert JSON if I want to. No, not too bad. And I can retrieve my video like that, or here I can retrieve a video from its ID. So I'm moving fast, but as you can see here, it's copy pasting. That's really following the instruction. Do it at your own pace later. So now in the database, we do have a table and a few record there. Let's have a look to what we are coming from the API. So here I'm going to the Connect tab and see all the way to access your data. So one is the REST API. So I'm selecting REST API. And here there is the Swagger. Okay, Swagger or OpenAPI is what existing in the REST implementation to show you what are the available resources, and also Swagger UI, here what you see on screen, will generate for you a client. So to use the API and know what the API can do, you don't have to install anything. You can just use Swagger for that. Okay, so let's do it, right? All right. Oh, I see you need a token to work. Okay, so to create a token, when you created your database, the screen gets you a token. If you forget to save it, you can create another one. Going to organization settings, token management, select a role. I will be a database administrator, and I will generate my token. Okay, so I'm doing that to have a token ready to go in my sample. Okay, I copy the token and I'm coming back here to the Swagger. Okay. So what you can do, first you can list the key space. So v2 schema, finding the resources, v2 schema key space, get access to all the key spaces in your database. Here, the token, oh wow, cool. Token is provided for me and I can execute and I get the same key spaces as I had over here, but as REST. Okay, I don't need to know anything about Cassandra query language. I can just, hey, give me all the database available. It will give me, hey, you have database KS1 and everything. That is retrieve. You didn't have to provide any parameters, to be honest. So now if I want to list the tables in the key space we created, so list get all tables, it's still a blue one. I will try it out. What is the name of the key space we are using today? KS1. And here we created this table called videos. Okay, cool. We got the tables. What about the types? Yes, we created a table and a type. So just moving quickly here. Here we got a type called video format, which is kind of the struct, an object you can reuse in your table. Okay. So now, hey, what if I want to create a table from this API? I should be able to do everything I want with the API. So let's find v2 schema key space table. v2 schema type, no, table, it's a green one here. Create a table. So try it out. The key space is KS1. And here we will create a table called users. Okay, copy, paste, execute. Okay, so let's see. So 200 is the code stating that the table has been created successfully. I should be able to start inserting data in this table. I can go back here, clear, describe tables, and my new tables has been created for me. That's cool. Keep going. So if I want to insert rows in this users table, I will go to V2 key spaces. It's a green one, and that would be add a row. Okay, it's not schema anymore. It's in data. V2 key space table name add a row. Okay, try it out. Key space name, case one. Table users. This is a table we just created. Create a first record and a second record. And again, another one. Okay. All right, so create the table, insert data in the table. So now let's read values. Show you that you get create, read, update, delete operation for you. So now if you want to retrieve all rows, here we go. Try it out. Key space, guys, one. Table name, users. Let's see. David, Kirsten, Cedric. I got my 3 records. Hey, cool. I can, so here the key in my table is the first name. If you look there, you see the primary key, use the first name. So I can also select and put a where clause on this first name. So this time, instead of retrieving all rows, I will search table. I will provide the same fields, KS1 and users. But this time, I will also provide a where clause. And the where clause would be first name David, for instance. And I think I moved to 3G a bit quickly. Okay, so here I did search a table, David. If I would just want to retrieve one row, and this is the one I skip, here you got the read a single partition. So it was here. I can do it quickly. Try it out. Key space, case one, users. And what we add as primary key was the first name. So if I use David, I got my record David. And I can do the same to delete my record. I provide the key space name, the table name. I provide David. And I execute. And now it told me the data is deleted. If I go back here and retrieve all the rows again, here I go, try it out. Guys, one, users. Now I only have 2 rows. So that's pretty cool to create a table, insert, delete everything using HTTP only and without touching Cassandra at all. Also, it's stateless, no need to maintain some connectivity. That's pretty convenient. Okay, so keep going. Another way to interact with the database is to use here called the document API. And so instead of here you can get not the key space but the namespace. It's even simpler. Instead of creating tables, we will work with collections, like MongoDB, if you're familiar with. You create a collection and you insert whatever you want in the collection. So no schema needed anymore, no validation, super flexible for the front end. That's quite cool to be able to use either strongly typed table or loose schemaless collections. So I got the list of my namespace. So KS1 is still there. This is what we expect, right? So create a document. So this time, create a new document over here. So I'll try it out. Namespace ID, KS1, the same. Collection ID. Let's use col1. We can use whatever we want. And here again, we can put any valid JSON. There is no schema, so you can put here whatever you like. And you insert. The first time getting a bit time because you need to create the collection and you get a document ID. See? And you can retrieve the document from the collection. So here we are going to search document in a collection, namespace KS1, collection col1, we just created that. And let's see if I execute that. I get my document with the ID and the field. And you can change the structures, not a big deal. That's remember document-oriented API. So retrieve the document, find the document by properties, you got the ID. I would like to get a chance also to show you the latest available API called GraphQL API. And here we go. So closing. I will leave for now. Okay. Going back here on the home page of Astra, on my database, connect. And now it's instead of REST API, I will go to GraphQL API. Playground. Okay, so here, first I need to so the token is provided, so I can immediately invoke, get a list of key space, and see that KS1 is there as well. So this tool is called the GraphQL Playground. To provide to you again to interact with the GraphQL API. I told you that GraphQL was cool because it exposed a schema, and the GraphQL Playground allow you to navigate and explore the schema to see what are the different types available and functions available. So here you can create a table, alter a table, drop table. Queries are for read-only. Mutation are for editing data, so update and delete, create, update, delete, and this one is for the reads. Okay, so if I want to create a new key space, okay, so let me go to my database and create a new key space. Add key space library. Okay. So let's wait for 1 second for this key space to create. Here, library. Okay. All right, and now I execute key spaces again here, and I do have my library created. Okay, so let's create a table in this library key space. So here I'm using a mutation. So using create table books. On the key space library, table name is book, partition key, and I also create a table authors. Okay, so 2 table created. That's cool. Now, if I want to insert data in the table, I will move from this tab to the GraphQL tab, putting the key space I want to use. Library. Okay. Checking my token, it's there. So from here, I should be able to execute that mutation and get my 2 data inserted. Okay. And if I want to retrieve the data, I can simply just get my queries over here. See, the record is there. Pretty cool, right? Okay. And that was it for the demo. At least you get a feeling of the REST, GraphQL, and document API exposed on your tables. And as you can see, you can try learn without even coding anything. Okay. So all the materials slide are on the GitHub repo. But if you want to know more, the Stargate comes with some SDK client. You don't have to code the request I show you on screen today. You have some Java, JavaScript, and Python libraries for you to shape all the requests with Fluent API like what you see on screen to get what you need. So more sample code, how to do a search, as you can see. Query builder, where on paging side is way easier than doing it with HTTP. So last slide. If you like this step-by-step instruction format, we are live every Wednesday on YouTube, and we will have a session. So June 29th in 9 hours, explaining deep dive of GraphQL. So, think about coming later today. So thank you. We are at the end of the session. I'm 5 minutes late. Where we start 3 minutes late as well. Again, if you want to join my network, here is my coordinates. Feel free to invite me, and let's get in touch. I will stay in the room a bit for any question. Thank you very much.